Hello everyone. Up till now in the Z transform we have studied Z transform, different techniques and properties of obtaining Z transform of the given sequence. We also studied how to find inverse Z transform. In that we studied the three methods to find inverse Z transform. Now in today's lecture we are going to study how to solve difference equations with constant coefficients using techniques of Z transform. So let us see what is meant by the difference equation. Difference equations with constant coefficients are the relation between f of n and f of n plus 1, f of n plus 2, so on. Similarly, f of n minus 1, f of n minus 2, so on with constant coefficients. So as like the differential equation, as we know, we will be getting differential equation in case of continuous systems and difference equations in case of discrete systems. So there differential equation contains different derivatives of different orders, and here in the difference equations we will be having the terms f of n plus 1, f of n plus 2, so on, f of n minus 1, f of n minus 2, and so on, and their coefficients must be constant. So what will be the solution of such difference equations? Solution is nothing but the sequence f of n which satisfies the given difference equation, and that f of n, it must be in terms of n. Whatever the examples we are going to study, in that we are going to consider this f of n as causal sequence, means sequence whose terms are 0 for n strictly less than 0. Now we are going to see procedure to solve difference equation. Procedure is very simple. There are only 4 simple steps, which are: in the first step we are going to operate Z transform operator on both the sides of the given difference equation. In the second step we are going to obtain Z transform of each of the term on both the sides using linearity property. Then in the third step, we are going to simplify that expression and we are going to obtain f of z in terms of z, that is z transform for the given difference equation. Once we get f of z, then we are going to operate inverse z transform operator on both the sides, and we are going to find sequence f of n, which will be a solution to the given difference equation. And to obtain this inverse Z transform, we can follow one of the three methods of finding inverse Z transform, which are power series method or partial fraction method or inversion integral method. As I discussed, in this lecture we are going to consider causal sequence only. Therefore, we are going to mention some additional results regarding causal sequence. The terms which are appearing in the difference equation for which what is the Z transform, that we are going to mention as an additional results. So for the causal sequence, we have studied the shifting property, in that whatever the general result we have mentioned, from that we are going to obtain Z transform for the following terms. In that first is Z transform of f of n, sequence f of n, we are denoting it by f of z. Second, Z transform of f of n plus 1. For the causal sequence, it is given by z into f of z minus z into f of 0. Third, Z transform of f of n plus 2 is equal to z square into f of z minus z square into f of 0 minus z into f of 1. Fourth one, z transform of f of n plus 3 is equal to z cube into f of z plus minus z cube into f of 0 minus z square into f of 1 minus z into f of 2. So these are the Z transform for the left shift property. Now consider the right shift. So Z transform of f of n minus 1 is equal to Z inverse of f of z for the causal sequence, and Z transform of f of n minus 2 is equal to Z raised to minus 2 into f of z. So these are some additional results which will be very useful while solving difference equations. Now, let us go to solve some difference equations. Consider the first example. Obtain f of n given that f of n plus 1 minus 2 f of n equal to 3 raised to n. So clearly we can observe here, this is the relation between f of n and f of n plus 1, and coefficients are constants. So clearly this is difference equation with constant coefficients for n greater equal 0, and we have been given the initial condition that if at n equal to 0, f of 0 is equal to 0, and we want to solve this difference equation and to get sequence f of n, which is solution to this difference equation. So let us see the solution. Whatever difference equation is given to us, operate the Z transform operator on both the sides. So that will gives us Z transform of f of n plus 1 minus 2 into f of n is equal to Z transform of 3 raised to n. On the left hand side, use the linearity property. So that will gives us Z transform of f of n plus 1 minus 2 into Z transform of f of n equal to Z transform of 3 raised to n. Now get Z transform of f of n plus 1, f of n and 3 raised to n using the formulas which we already knows. For the first term, Z transform is Z into f of z minus Z into f of 0 minus 2 into f of z equal to Z divided by Z minus 3. This is for n greater equal 0. Now, we have been given that f of 0 is equal to 0. So, we got this expression. Now, simplify this expression for f of z. Take f of z common. So, we left with z minus 2. Now, divide on both the sides by z minus 2. That will give us f of z is equal to z divided by z minus 2 into z minus 3. So, see, in this way, we got the term f of z. Now, we want to find inverse Z transform, for which here we are going to use partial fraction method, in which we are obtaining partial fractions of f of z upon z. So get that term. Therefore, f of z upon z is equal to 1 upon z minus 2 into z minus 3. Get the partial fractions of this RHS, which are 1 upon z minus 3 minus 1 upon z minus 2. Once we get partial fractions, then multiply by z on both the sides. That will give us f of z is equal to z upon z minus 3 minus z upon z minus 2. Now, we want to find inverse Z transform, for which operate the Z inverse operator on both the sides. That will give us Z inverse of f of z, and on the right hand side we have used the linearity property of Z inverse, which gives us Z inverse of z upon z minus 3 minus Z inverse of z upon z minus 2. So using the table of inverse Z transform, get the inverse Z transform, which is f of n is equal to, for the first one it is 3 raised to n, and for the second one it is 2 raised to n. Therefore, f of n is equal to 3 raised to n minus 2 raised to n for n greater equal 0, which is the solution of the given difference equation. Consider the second example. Solve the difference equation, which is 4 into f of n plus f of n minus 1 is equal to 2 raised to n for n greater equal 0. Solution. This is the given difference equation. Now take z transform of both the sides like this to the left hand side. Now use linearity property. That will gives us z transform of 4 into f of n plus z transform of f of n minus 1 is equal to z transform of 2 raised to n. Take this 4 common and rewrite the expression. Now, using the formulae, get z transform of each of the terms in the expression. So z transform of f of n is 4 as it is. Z transform of f of n is f of z plus z transform of f of n minus 1 is z inverse of f of z, and z transform of 2 raised to n is z upon z minus 2 for n greater equal 0. Now, we will simplify this expression and we will be getting, we will simplify left hand side for f of z. Therefore, we will be getting 4z plus 1 divided by z into f of z equal to z upon z minus 2. Now, simplify this expression for f of z. Hence, f of z is equal to z square divided by z minus 2 into 4z plus 1. We have multiplied both the sides by z upon 4z plus 1, and we got this f of z. We are going to use partial fraction method to obtain inverse z transform, for which obtain f of z upon z, which is equal to z divided by z minus 2 into 4z plus 1. Get the partial fractions of right hand side, which are 2 upon 9 divided by z minus 2 plus 1 upon 9 divided by 4z plus 1. Multiply by z on both the sides of this expression. Therefore, we will be getting f of z is equal to 2 upon 9 into z upon z minus 2 plus 1 upon 9, and we have taken 4 also common. So 1 upon 36 into z divided by z minus of minus 1 by 4, to express it into a standard form so that we can obtain its inverse z transform easily. As we got f of z in most simplified form, so take or operate inverse z transform on both the sides. Therefore, we will be getting z inverse of f of z equal to 2 upon 9 z inverse of z upon z minus 2 plus 1 upon 36 into z inverse of z divided by z minus of minus 1 by 4. Now, using standard results, get the inverse z transform of these two terms, and we will be getting f of n as 2 upon 9 into 2 raised to n plus 1 upon 36 into minus 1 by 4 raised to n for n greater equal 0, which is the solution of the given difference equation. In this way, using Z transform techniques, we can solve the given difference equations. I hope you have understood this, and this is all about Z transforms. Thanks for watching this video.